Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is Geometric Sequences Basics. A geometric sequence is nothing but a sequence in which the ratio consecutive terms is constant. First, let us focus on what is common ratio. Let me give you. Since this ratio is common to all the consecutive pairs of terms, it is called the common ratio. It is denoted by R. If the ratio between the consecutive terms is not constant, then the sequence is not geometric. So this is one way of checking whether the given sequence is geometric or not. You can check the common ratio. If it is constant, then you can say that the sequence is geometric. This is the formula for common ratio of geometric sequence. R is equal to an plus 1 divided by an. Now let us see the general term. This is the formula for the general term of geometric sequence. It is denoted by an, which is equal to a1 times r raised to n minus 1, where an is the nth term, a1 is the first term, and r is the common ratio. So this is the formula to find the common ratio. Find what is a1, an, r, and plug in those values in this formula. A geometric sequence is an exponential function. Any exponential function would look like this. Am I right? Y equal to a raised to x. Here we write an is equal to some constant multiplied by r raised to some power, where r is the common ratio and this would be the constant. Okay. A recursive definition. Since each term is found by multiplying the previous term by the common ratio, just by cross multiplying, an times r will be equal to an plus 1. Am I right? This idea here is similar to that of the arithmetic sequence, except each term is multiplied by an additional factor of r. Am I right? The exponent on the r will be 1 less than the term number. The first term has not been multiplied by r at all because exponent on r is 0. Any number or term which is raised to 0 would be just equal to 1. Am I right? The second term has been multiplied by r once. The third term has been multiplied by r twice. It keeps on going like that. So, the general term of a geometric sequence is an equal to a1 times r raised to n minus 1. Hope you are clear with this formula? Okay. Now let us see what is partial sum of geometric sequences. Hope you have watched our previous video, arithmetic series. In case if you have any query regarding the topic, you can let me know. For more details about arithmetic series, you can watch a previous video. I'm going to use the same concept here. I'm going to assume some geometric series and I'm going to prove how to find partial sum using the given formula. Okay. A series is nothing but the sum of a sequence. We want to find the nth partial sum, or the sum of the first n terms of the sequence. We will denote that nth partial sum as 8 suffix n. Okay, I'll take one geometric series. Please consider this geometric series 2 plus 6 plus 18 plus 54 plus 162. There is a trick here that can be used to find the sum of the series. So in this series, what is the common ratio? 6 over 2 is 3. 18 over 6 is 3. So we find the ratio, common ratio for all the terms, for all the consecutive terms. That would be 3. Am I right? If r is equal to 3, what would be negative r? Yes, negative 3. Multiply both the sides of this equation by negative r, which is nothing but negative 3. If I multiply this equation throughout by negative 3, I'll get negative 6, negative 18, negative 54, negative 162, negative 486. Am I right? Now, just add these two equations together and notice that when you do that, all but the first and last terms cancel out. Am I right? We need the value for S5. So you can factor an Sn out of the left hand side and factor out 2 out of the right hand side of the equation. Am I right? So by doing so, we will get divide both these sides by 1 minus 3. Same as we did in the previous video, I'm not going to simplify here. I could have simplified this. If we do, you would get 2 minus negative 243 divided by negative 2, which would be equal to 242, a number. But you're probably wondering why I didn't go ahead and simplify. Well, when you're trying to make a conjecture about the general case, it does not usually help to simplify and lose the original values. So now, if we try to figure out where the different parts of that formula come from, and we can conjecture about the formula for the nth partial sum. Okay, the 2 in the numerator is the first term. Am I right? First term is 2 here. So A1 is 2. This 243 is nothing but 243 in the numerator is the ratio times the nth term. That makes it the n plus 1 term. A1 times r raised to n. Since both the terms in the numerator have an A1 in them, then it can be factored out. The 1 in the denominator is always 1 and the 3 in the denominator was the ratio r value. So this makes the sum of the first n terms. Sn is equal to A1 times 1 minus r raised to n divided by 1 minus r. There is an implied domain that r cannot be equal to 1, but since it is implied, it does not need to be stated. The formula for nth partial sum of the geometric series is going to be A1 times 1 minus r raised to n divided by 1 minus r. Hope you are clear with this one. We have discussed what is partial sum in geometric sequence. Now let us see what is infinite sum in this topic. There is another type of geometric series, an infinite geometric series. An infinite geometric series is the sum of an infinite geometric sequence. When the ratio has a magnitude greater than 1, the terms in the sequence will get larger and larger. And if you add larger and larger numbers forever, you will get infinity as an answer, right? So we don't deal with infinite geometric series when the magnitude of the ratio is greater than 1. The magnitude of the ratio can't equal 1 because the series would not be geometric, and the sum formula, what we just discussed, would have division by 0. The only case left then is when the magnitude of the ratio is less than 1. For example, consider r is 0.5 or half. A sequence might be 1 half, 1 over 4, 1 over 8. It keeps on going like that. As the sequence go on, the terms are getting smaller and smaller and it approaches 0 at one point. Hope you remember that I said earlier that a geometric sequence was an exponential function. What happens to an exponential function when the base is between 0 and 1? It was asymptotic to the x-axis, to the right. Am I right? That is, as x approached infinity, y will approach 0. Well, the same thing happens here. As n approaches infinity, r raised to n approaches 0. So if you replace r raised to n with 0 in the summation formula, this part, if n approaches infinity, r raised to n approaches 0. So if you replace r raised to n with 0 in the summation formula, this part, 1 minus r raised to n part just becomes 1 and the numerator just becomes a1. So this would be the formula for the sum of an infinite geometric series. This infinity symbol denotes the infinity, which is equal to a1 over 1 minus r. Hope you're clear with this formula now. These are the key basics in this topic. You should know the formula for the sum, partial sum, infinite sum. You should know what is meant by common ratio. Hope you're clear with these basics. In case if you have any related topic for geometric sequences, you can let me know. Let's discuss problem solving on geometric sequences in our upcoming videos. In case if you have any query regarding this topic, kindly let me know. See you in the next video. Have a great time ahead.